Okay, so we look at polar coordinates. So I want to use the polar coordinates to show that the integral of this is going to be pi over 14. So we look at the solution. So first we know that r squared is equal to x squared plus y squared. That's the relationship between rectangular and polar. So in this case, we know that where there is x squared plus y squared, we're going to put r squared. So already our I has moved from 0 to 1, 0 to root 1 minus x squared. This part here will be r squared, and then we have 5 over 2, and then dy dx. Now, this order means that 0 is less or equal to y, which is less or equal to 1 minus x squared root. So when we let y to be equal to 1 minus x squared, if you square both sides, then we get y squared is equal to 1 minus x squared. And this is just the same as x squared plus y squared is equal to 1, which is a circle of radius 1. So if we draw that circle, we have it of radius 1. Okay, 1. But because x is running from 0 to 1, from 0 to 1, this means that, so x is here from 0 to 1. This means that we are dealing with a semicircle. Okay, so we are concentrating in this circle, and the only part that we are taking care of is the part in the first quadrant because of the limitation of x from 0 to 1. So what happens is that this will force theta now to run from 0 to pi over 2, because we're just dealing with the first quadrant. And then, so theta will come from 0 to pi over 2. And then r will come from 0 to 1. R will come from 0 to 1. And so we have r, this is just r to the power 5. And the dy dx, when we change into polar, remember, it comes with the r and the r and the theta. So we have from 0 to pi over 2. When we integrate this, we get r7 over 7 from 0 to 1, the theta, which is, when we substitute, we get 1 over 7 d theta. When we integrate, we have theta over 7 from 0 to pi over 2. When we substitute where there is theta, we put pi over 2. We get that minus 0, and this is just pi over 14. So as required here. So just showing that it's pi over 14. So this is how we change the order. This is how we use polar coordinates to disturb the order, or to change from rectangular into polar. So the key thing is that when you bring in the r d theta, it comes with the r, because the assumption is that r is going to be this function. And so that's why we have that. And then we have changed this using this relationship. And the limits for theta, they are guided by the limits for x. So x is 0 to 1, meaning that we only take care of the first quadrant. And so theta gets us restriction from 0 to 90, because we understand that this is 90. If we get here, it would have been 180. It would have been 180 if we allowed x to run from -1 to 1. But now x is only running from 0 to 1, meaning you are just in the first quadrant, where we have this as pi over 2, 90. So we have 0 to pi over 2 for theta. So this is theta. So Let me just redo this part nicely. Okay, so I have this. So this is theta. So starting from 0 here, and x, this is x, which in this case we're taking it as r. So we have 1, so 0 to 1, and then 0 to theta, but this part is pi over 2, which is 90. And because r is from 0 to 1, then you're dealing with the first quadrant, where theta will be from 0 to pi over 2. And that's how we got these limits for theta. And for r, they came from that guidance. So this is our integral. Thank you.